Hello everyone, I hope all of you are fine. So my name is Shubham and today we'll be starting with the next chapter for class +1 physics, that is units and dimensions. Okay, and this is the chapter that we'll be starting जहाँ से अपनी physics actually शुरू होती है, means from there the actual syllabus begins. Out of these chapters, that is the units and dimensions, the first topic is physical quantities. Physical quantities are all those quantities which are used to describe the laws of physics. We have studied a number of physical quantities till date for physics, like mass, velocity, acceleration, speed, distance, displacement, current, magnetic field. So these all are physical quantities. Okay. They can be classified as follows. First classification is based on their directional properties. Now we know that based on their directional properties, the physical quantities can be defined in two ways. First is the scalars. Scalars are those physical quantities which have only magnitude but no direction. And vectors are the physical quantities which have both magnitude as well as direction and obeys the laws of vector algebra. Now what are these laws of vector algebra that we come to know later on when we start with the vectors. For now you can just learn the definition part of this, that is scalars are those which have only magnitude, for example mass, density, volume, time. And vectors are those which have magnitude as well as direction, for example displacement, force and velocity. Acceleration is also there. Okay. The next important thing that we are going to study is based on their dependency. Now what does this dependency means is, physics में जितनी भी quantities हैं, they have been basically divided into two. First is the fundamental or base quantities and second is the derived quantities. Fundamental or base quantities are such quantities which are independent of any other quantities. We have total 7 fundamental quantities in physics which we'll learn later on in this lecture. And the derived quantities are those quantities जो हमें fundamental quantities की help से मिलती हैं. For example, let's say distance is first fundamental quantity, time is second fundamental quantity, and let's say third could be mass. Mass is third fundamental quantity, है ना. तो जो भी इन fundamental quantities की help से हम define कर सकते हैं. For example, we can define speed. Speed is equal to distance upon time. So we need two basic quantities or two fundamental quantities, that is distance is the first one and time is the second one, just to define a quantity which is known as speed. So speed becomes our derived quantity and fundamental or base quantities are total 7 in number, as I've already told you. These are the few details or few golden key points that you need to keep in mind when you go through this chapter. First is the fundamental physical quantities can also be classified as dimensional or dimensionless and constant or variable. इसके बारे में भी अभी हम थोड़ी सी देर बाद पढ़ते हैं कि dimension का मतलब क्या होता है और dimensionless का मतलब क्या होता है. Second is, so right now I am putting a question mark on this. Second part is, some physical quantities cannot be completely specified even by specifying their magnitudes. Now such quantities are known as tensor quantities. Means the quantities which are neither scalar nor vector. ना वो scalar होती हैं ना vector quantities होती हैं. Such quantities are known as vector quantities, and in whole +1 physics we have only one tensor quantity, that is moment of inertia. And moment of inertia we'll learn about in chapter number 6, that is rotational motion. What is moment of inertia? For now you can simply learn the definition. Means tensors are such quantities which are neither scalars nor vectors. Okay, let's try this illustration. Classify the quantities displacement, mass, force, this under the following categories: base and scalar. This is the solution for this. I hope this is a very simple question. You can try it on your own. If you would be having any doubt, we can of course discuss in our doubt class as well. So this is the solution for this question. Go through this, and if you find any problem at all, you can of course ask me anytime. These are the units of fundamental quantities. Means we know that 1 kilometer is equal to 1000 meter and 1 meter is equal to 100 centimeters. So these are the units that we've already learnt in our previous classes. But there are a few units, there are a few systems rather in which these units have been divided. So the next topic is system of units. Now what does this system means? It says that the chosen reference standard of measurement in multiples which a physical quantity is expressed, मतलब physical quantity को जिन terms में हम express कर सकते हैं उस चीज को हम एक system बोल देते हैं. First system is FPS system or British engineering system. In this case the base units have been taken as foot, pound and seconds. You must understand this thing that every system will have some fundamental quantities and some derived quantities. So these are the three fundamental quantities for the FPS system or British engineering system. Foot is used for length as fundamental quantity. Pound is used for mass as fundamental quantity, and second is used for time as fundamental quantity. So when you are asked about the fundamental quantities for FPS system, you'll simply say foot for length, pound for mass and time for second. Next is the CGS unit or Gaussian system. CGS units take into consideration as centimeter for length, gram for mass and second for time. So as you can clearly see in these two units, that is FPS units and CGS units, we have only three fundamental quantities, that is length, mass and time. So these are the units in which these length, mass and time are measured. Next unit is MKS system. In this system also the fundamental quantities are length, mass and time, and units would be meter, kilogram and second. जहाँ पे इस केस में लेंथ हमने फुट में मेजर करा, in this case we have measured it in centimeter, in this case we'll measure it in meter. Mass is in pound, mass is in gram and mass will be in kilogram, and this the time part is constant or common for all these systems. And in this case as well, that is MKS system as well, we have this time in seconds. Okay. Fourth unit is International System of Units. This is one of the most important units and most used units, I would rather say. So the quantities, the 7 quantities that I was talking to you about earlier during this lecture, these are those 7 quantities. Length, mass, time are 3 fundamental that we've already discussed in the few previous units as well. Fourth is the temperature, fifth is the electric current, luminous intensity and amount of substance. Now length is measured in meter in this case, mass in kilogram, time in second, temperature in Kelvin. We need to take care of this thing that normally a temperature is measured in degrees Celsius, but as far as the standard units or system international units or SI units is concerned, the temperature is to be measured in Kelvin. Okay. Electric current is measured in ampere, this we already know. Luminous intensity is measured in candela. Candela is represented as CD, and amount of substance is measured in mole. This you have learnt about in your chemistry as well, what is mole. So 1 mole of substance means 1 Avogadro number, and Avogadro number has the value 6.022 into 10 raised to 23. Okay, and you have learnt a part of it in your class 9th as well. Now as far as this luminous intensity is concerned, luminous intensity means, for example, this is a light source and this is a particular surface. Now from the light source, the light rays will be falling on this surface at all the points. If we consider any particular point and we try to calculate the energy falling per unit area for this particular region, I am repeating it again. If I try to calculate energy falling per unit area per unit time for this particular area, then we will get the intensity. मतलब इस area पे per unit time, per unit area कितनी light energy गिर रही है, that will give us the luminous intensity, and that luminous intensity is measured in candela. Okay. So this is the major point that we need to take care. Why do we need to define the units? ऐसी ज़रूरत क्यों है या इसके what are the properties of these defined systems? First is they are well defined. Of course, it is clear that they all are well defined, means they have different units for mass, length and time, so they are indeed well defined. Invariability means constancy means normally in India SI system is used, and the SI system would be same throughout the India. ऐसा नहीं होगा कि पंजाब में हम लेंथ को मीटर में मेजर कर रहे हैं और अगर हम किसी और स्टेट में जाएंगे, लेट्स से हम लोग कोलकाता चले गए या वेस्ट बंगाल में चले गए और वी गो टू MP और वी गो टू केरला, एनी अदर स्टेट, उसमें लेंथ हम फुट में मेजर कर रहे होंगे एसआई सिस्टम में. इट वोंट बी समवट लाइक दिस. सो दिस इज कांस्टेंट, द सिस्टम्स आर कांस्टेंट. जो भी आपने सिस्टम अडॉप्ट कर लिया वो पूरी की पूरी जगह पे सेम रहेगा. ठीक है. Accessibility. Accessibility means these are easily available. Easily available means we have certain rulers for this, we have certain weighing scales for this, so these can be easily available. Reproducibility means it can be reproduced. Can be reproduced means they can be converted from one unit to another unit. For example, 1 meter is the SI unit in what you can say in length, and 1 meter is equal to 100 centimeter. If I convert this 1 meter into 100 centimeter, now I have moved to CGS unit, because centimeter is such a unit which is used for CGS. There you can see in CGS the SI unit for length is, sorry, the CGS unit for length is centimeters. Okay. And the last part, of course, this is convenience for use. Convenience for use means they can be easily conveyed. So not easily conveyed, they can be easily used, है ना, आराम से हम उसको यूज कर सकते हैं. तो these are the things that you need to take care, and you can go through this video and this topics. We'll continue it in the next one. Thank you.